Okay, the second thing we like to talk about in this section is symmetry. So from geometry in your past, you've learned about just different types of symmetry, hopefully. Reflection symmetry, like if something has vertical symmetry, like, whoops, like the letter V. It's got a vertical line of symmetry to it, same on both sides. You know, the letter B, if I draw it right, it's got a horizontal line of symmetry in it. So with functions, we have two particular types of symmetry that we like to look at. One is symmetry about the origin, and one is symmetry over the y-axis, although you could have different kinds of symmetry on the graph. So I'm going to look at two functions to start. We've got f of x equals x cubed. This has what we call symmetry about the origin. And here's how you know that. It's basically the same as what we would call 180-degree rotational symmetry. So I'm going to take this graph of x cubed, and I'm going to rotate it upside down. I'm going to rotate it, not flip it. And if you look, it's the same graph. That's what tells you. So the red part looks the same whether we have it normal or whether we rotate it 180 degrees. So that makes that what we call an odd function. So this is what we call odd. X squared, on the other hand, that does not have that rotational symmetry. So I can grab it, I can rotate it, and as you see, instead of a parabola opening up, it's now a parabola that opens down. So that's not what we call an odd function. But it is what we call an even function. And what we look for in an even function is, if we take that graph, and I'm going to choose transform, interestingly enough, we've been talking about transformations. I'm going to do mirror in y-axis, meaning I'm going to reflect it side to side across the y-axis. And when I do, I get a new image, boom, and the graph looks the same. So if you look closely, you can see that it is a mirror image of what I had there. If that happens, that is known as an even function. Now, it's no surprise here that if you noticed, x cubed is an odd exponent and x squared is an even exponent. We're going to look at Desmos real quick again. And if you look, I can graph any combination of odds. So if I go x to the 5th power minus x to the 3rd power, it still has that rotational symmetry. And if I do any combination of even powers, like say x to the 4th minus x to the 2nd power, that green graph has the symmetry over the y-axis. Now, the moment you incorporate a constant in there, like in the first one, say minus 6, well, now it has neither. When we rotate it, it's going to go from the bottom of the graph to the top of the graph. With an even function, though, incorporating a constant still has that left-right y-axis symmetry. Now, it doesn't have to be just functions with exponents in them to be considered odd or even. You can explore any, trigonometric functions, which we don't really do in this course, but sines and cosines, radical functions with roots, they all qualify. So we can do it without a graph. Here's how it's defined. So if you plug in negative x and the function doesn't change, that's an even function. If you plug in negative x and the entire function is the opposite of what you started with, then it's an odd function. Let's go back to that last page real quick and clear this out. So here's what we mean by that. If I take x cubed and I put a negative x in place of x, well, when you cube a negative and kind of simplify out the parentheses, it's negative x cubed. Negative x cubed is the opposite of x cubed, the entire opposite. That makes it odd. Second one, if I put a negative x and I square it, well, when you square a negative, it's positive. That's the same as what you started with. That makes it even. So I had one example here. What about f of x equals x over 2x minus 1? Well, let's try it with the algebra first, then we'll check a graph. So what I'm going to do is everywhere I see an x, I'm going to put a negative x. And then I'm going to simplify. So I have negative x over negative 2x minus 1. Now sometimes in a problem like this, you have to kind of clear up these parentheses and see what happens. So one thing I see is every single spot's negative right now, so I could just put a negative out in front of the whole thing and have x over 2x plus 1. Wow, that looks really close to being the opposite of that, right? Because there's a negative out in front of the whole thing, but not quite. That little plus 1 is not the minus 1 from the original, so it's not a complete opposite. Therefore, this one is neither. That's an option. You could be even, odd, or you could be neither. Let's take a quick look at this one. It was x over 2x minus 1. Clear out these, and we will graph x over 2x minus 1, and there it is. You can see, obviously, it does not have symmetry left-right across the y-axis. It almost has the rotational symmetry, but it doesn't, because this tail over here to the right is going to rotate down into the third quadrant and not match up with this one there. So there's lots of symmetry on graph. We focus on the functions being even or odd or neither of those.